we're going to come back and we're going to continue our discussion on these arithmetic sequences. Okay. Okay. So let's start off with the slideshow here, where we left off. Okay. And now we're talking about what we call geometric series. Okay. I'm sorry, arithmetic series. Geometric will be coming up next. Okay. So we had understood, we looked at these previous sequences, 5, 8, 11, 14, 17. We called these sequences arithmetic, in that each term differs by a constant amount from the previous term. Okay. Now, when we add all the terms of the series, of the sequence, we have a series, okay, which is more or less what we'll end up looking at to a greater extent. So the series is just nothing more than putting a plus sign between each of the members of a particular sequence, okay? So obviously one of the things we're going to want to do is find the sum of however many terms in the series. Let's sum up the first 50 terms. Let's sum up the first 1,000 terms, okay? Let's sum up the first 1,000 terms without having to generate the 1,000 terms. All right, so that's the approach we want to take. Find some kind of formulation that's going to do the sum for us. All right, so we're going to do that by way of an example, and then kind of generalize it from there. Okay. So again, typically we're concerned with finding the sum of the first n members, where n can be that number 50, 100, 200, 700, whatever. Okay. So the generalized expression is the sum, the big S, of however many n terms is just all those terms, the first, the second, third, all the way out to the nth term. Now, we generally will start off the first term as an A and then sub the rest of them, okay? This is the last term, maybe the 50th term. This would be the 49th term. So generally speaking, the last term would be the nth term, and the one prior to that would be the nth minus 1 term, and the n minus 2 term, and so on and so forth. So let's say we had the numbers from 1 to 100, the integers from 1 to 100, and we wanted to sum them, okay? 1 plus 2 plus 3 plus 4. So, and obviously, okay, we have better things to do than to just record the manual sum of them, so we approach it in the following way, okay? So I could say that the sum of the first 100 terms is, generally speaking, the sum of the first 100 terms is, you know, as generated here. I'm not going to write them all out, so I use the notation as stated here, and okay, I write out the first couple, and then I write out the last couple. All right, and and if we take the sum of the first 100 in reverse, it shouldn't make any difference. The sum, because addition is commutative, so I could go either way with it. So the sum of 1 through 100 in increasing order, and the sum of 1 through 100 in decreasing order. If I now add, okay, each of the columns, look at what I obtain. Okay, so if I add the left-hand side, I'm going to have twice the summation that I really desire. So I just look at that as 2 times the sum of 100. But the first and the last term here is 101. The second and the second to last term is 101. The last term and the first term is 101. So basically, I have nothing more than 100 101s, and this looks like it should be 101 here, not 100. Okay, so what I've done is I can say that twice my sum is 100 times 100, or my actual sum is, okay, my actual sum is 100 times 101 over 2, which is 5,050, okay? So again, what did I do? I took all my series terms in increasing order, all my series terms in decreasing order. I added them column for column. I got twice the amount I wanted. What I ended up getting was, okay, 100 times 101. But then that was twice what I want, so I divided that by 2. Okay, so generally speaking, what I've done is, okay, 100 is the number of terms that I'm trying to generate. So that's the n value in general. Okay, the 101 is actually my first term and my last term. So I'm adding up in the parentheses here the first term and the last term, the 8th term and the 8th term. All right, so there's a summation formula. Now previously we had showed you that you can find the nth term in a arithmetic sequence by this formula enclosed here, okay, which is the first term plus the n minus 1 times the common difference, all right? And so we can condense that and put this into this form right here, okay? So we have now a formulation for finding the sum of however many terms, n terms, of an arithmetic sequence, okay? So that's pretty much your arithmetic sequences. We will resume with the discussion of geometric sequence in the next video.